So in the previous videos, we're taking a look at how muscles are set up in terms of the sarcomeres, in terms of the muscle fibers themselves, and kind of the different layers and bundles. And we also took a look at how does this muscle fire, okay, the steps leading up to the sliding and through the sliding filament theory. But let's take a look at some of the other parts that's all part of this. Now, the muscles themselves have to have their own firing system. They have to have the motor neurons, those consciously controlled nerves that are leading to it, telling the muscles to fire and regulating all of that. So we refer to those as somatic nerves. These are voluntary nerves that work to just the skeletal muscle. And so really when we talk about muscles and how they fire and the physiology of everything, we have to talk about the entire motor unit. That includes the nerve itself, that it gets a conscious control from the brain, turns it on and stimulates there. And it talks about all the fibers that this nerve is going to be affecting. Okay, it's not like we have one nerve for every single fiber in our muscles. That doesn't make any sense. What's going to happen is it has this broad overlying kind of sits and hovers over there and stimulates the other muscle fibers to help each other out. And so this will allow the muscle to overall respond in different levels, allowing for a weak universal contraction. So it's not like there's one nerve going to one fiber and it's controlled or micromanaged in that way. And other way to describe it is just allowing those muscle fibers to work in shifts and what we call the all or none response. And so what happens is when you get this big muscle structure and we have all these different fibers in there, certain muscle fibers are going to be stimulated. They're going to go 100%. It is all effort. There is no like a rheostat where I could turn down the light and turn it up and like this. It doesn't work that way. Those muscles are firing, or those fibers are firing 100%. And so that will tire, that'll fatigue. And as it shuts down after that fatigue, what's going to happen is it will fire the neighboring fiber to start firing. And so that's what I mean by working in shifts. And sometimes when you add too much of a load, the muscles all get really shaky and you start quivering, that kind of thing. What that is the muscle fibers are firing, they're fatiguing, they're waking up the next one. It's already fatigued, so it picks up the load and then it shuts down and wakes up the next one. And so that's what we mean by the all or none response, is that those individual fibers are stimulated to fire and they go 100%, or they don't go at all. There is no in between, and they'll fatigue, they'll shut down and wake up the neighboring one and share the load that way, working in shifts. Okay. Now, this is a good picture that shows what I was just describing. We have the nerve that sits and hovers over this muscle cell. On the inside are all those little fibers. And so when we talk about the sliding filament theory, we talk about the mechanics of all that. I'm not going to go through that in this video. Check out the other videos for how that works. But we have some terms that go here. Here's the synapse, okay? The gap in between. Here's the synaptic knob. Here's the end of that nerve where we see the acetylcholine and all that fun stuff that we talked about in the video. Here's that gap that sits, and it's not like the nerve is sitting on the cell itself. It hovers just above. There's a little gap there, and that allows for the chemical reaction to happen on the inside as well. So that's that neuromuscular junction, okay? The junction between the nerve and the muscle itself. Now, we've looked at all these. I want to skip through those because that's with the other videos. And we'll pick up the story from there. We see the stages of contraction is what I wanted to get to. So for all the mechanics of the sliding filament theory to happen, it needs to be a certain amount of voltage required. Not all voltage going through. That'd be way too much, way too maintained. We have a certain threshold. And as nighttime goes, your threshold goes down. And so you're a little bit more sensitive to that. In the daytime, your threshold is up higher. So even time of day and your activity level, if that threshold is met, the voltage is enough, then the calcium is released and you got the sliding filament theory going in action. There's a delay called the latent period. There's a delay for the mechanics of that, and the muscle will actually contract. And then remember, in the last phase of the sliding filament theory, you have to undo the process to relax and reset the system. And notice that that's about 5 times longer than it is to flex in the first place. So it's a very quick to flex, but it takes about 5 times longer to relax. And this is where a lot of the sports therapy is coming in. A lot of the training and everything else is how do we reset that system even faster? So a good warm down, stretching out, reboot the system. That's going to allow for a lot more muscle contraction a lot faster. Okay. Now the muscles will respond in different levels. okay, to that stimulus. And so it comes in different waves. With a very low stimulation, that muscle, maybe you hit your threshold, but the muscle will just kind of, it'll be just a slow, steady, and it's going to have just a very low, it's a full relaxation in between. Very low stimulation. You're not going to get a big muscle response. And the muscle, that twitch can keep going very rhythmically for a very long time because there's full relaxation in between. Now, we add a little bit more stimulation to that, a little bit more energy, and you're going to see that it's still relaxing every time, but each and every time that muscle is contracting higher and higher and higher. And so it's getting almost like it's going to be getting into almost like a muscle cramp. You can feel it coming. That's what it kind of feels like. You can see that muscle is contracting stronger. You up that voltage just a little bit more, you're going to be getting what's called an incomplete tetanus. So what's happening is, just like a trap is going to be going up and up and up, the difference is a tetanus will not relax. So it won't fully extend again. It'll be actually staying a little bit contracted, and the strength with which it's going to be flexing is going to be increasing each time. So it's not relaxing each time. It's going to build on the last one. And so we also refer to it as wave summation. And then we have the full-on contraction, where basically those twitches do not relax. That muscle is just locked until it fatigues and lets go. Okay, so that's a complete tetanus. Okay, so the difference is there. Kind of graph it out a little bit. You'll see what we mean by that. Now, those muscles will just be flexing in two different ways. We think about it in terms of physics. If you're pushing something but you don't get any movement, then no work is being done. But we know that's not true with muscles. There's two different types of contraction that muscles can do. We can flex a muscle without actually moving the muscle at all, okay, remaining tonus or pushing against something. We always do that party trick where you're kind of standing in a door frame and try to lift your arms up and work as hard as you can, and then you step out of that door frame and it feels like your arms just kind of naturally float up on their own. That's isometric. The muscles themselves are flexing, but they don't change in length at all. They can't. They're being inhibited. That's an isometric, and you can do a lot of strengthening and toning work with isometric exercise. Now, the other type that involves a lot of movement is called isotonic. Now, one of the things when you're doing muscle conditioning, you got to keep in mind that isotonic, to optimize that, the muscle you need to kind of consciously control as it shortens. But certainly that's the concept, but also to slowly let that muscle lengthen as well. So you fight it going up as well as going down. Think about it in terms of the weight room, where you're doing just a bicep curl. You're going to be curling up, okay, so the muscle is getting shorter, and so that is what we call a isotonic concentric. The muscle is getting shorter. But if you're doing it right, you should slowly let that arm down again. Okay. And so you don't just let it go limp and just fly off again. You want to slowly let it lengthen. And that's what we call isotonic eccentric contractions. So focusing on that with muscle conditioning is important. Now, all the point of all of these things, and just kind of the thing that we all understand about muscles as they're flexing, they burn oxygen. Okay, the oxygen is used to make the ATP from glycogen. If you think about cellular respiration, it all happens in the powerhouse of the cell, the mitochondria. So the oxygen is used, but if you're running out of oxygen, that's referred to as oxygen debt. Okay, this is anaerobic exercise, and so what happens is that glycogen doesn't have enough oxygen, and it forms lactic acid. That's that burning sensation, and so the muscles can't do anything with that. You don't get ATPs either; they run out of energy. Okay, so that is part of it. Now, if you're a fast twitch type muscle, it means that you're very good and very powerful, very fast firing. However, they're horrible in processing oxygen. These do not have good endurance. So very speedy muscles. They tend to be bulkier, but they have very low tolerance for oxygen. If you're running low on oxygen at all, these guys fatigue very quickly. Nobody sprints in regular high school or even college levels or whatever. Unless you're really, really training super hard, you really don't have these big, fast twitch muscles that are able to sustain a sprint past like 400 meters or whatever. I know that you take a look at college level and into the Olympic level training and everything. They're sprinting the 800 and they're sprinting the mile. But in terms of that, typically we have fast twitch muscles or they're sprinters muscles. Now, very slow, low endurance with those. Now, slow twitch muscles, I kind of hate this description or this name, because it implies that these muscles are slow. They're not. It just has, the problem is they're very slow processing compared to the fast twitch. So you don't have that kick at the end. You're not speedy with it that way. But you do have the benefit to this is very, very tolerant with oxygen. So they are working with really high endurance. And so these are kind of your distance runner type muscles. They can run forever and they never fatigue. They never build up the lactic acid compared to the counterpart of the fast twitch. And so that's the difference with that. So if you're a sprinter, I guess the concept is, if you're naturally built for kind of fast twitch muscles, work on your endurance, work on your slow twitch muscles. If you're naturally built for kind of the endurance marathon and distance running, well, work on your sprints, work on your fast twitch muscles to get that kick at the end, and so on. And in doing so, then what you get is a blend in what we refer to as intermediates. Okay, now let's take a look at some muscle disorders. Muscle disorders like muscle cramps. Muscle cramps is going to be when you have the sodium potassium pump, or maybe your calcium levels are off, and that irritates the membrane and kickstarts that sliding filament theory. It initiates a muscle contraction when it wasn't consciously controlled. Fibromyalgia is just a general disorder. We're taking a look at just pain and tenderness. It's caused by maybe an irritation of the muscle membranes. It could be caused by physical, emotional trauma or medications. People are self-medicating. They're taking all these nutrient supplements and they're having a buildup into the muscles themselves. So that's just called fibromyalgia, general soreness of the muscles themselves. There's atrophy, and this is the problem when people are going on bed rest. You have to have therapy. You have to have people moving the muscles if you're on bed rest. Try to do that, because a friend of mine, she was doing her doctoral thesis on this, talking about if you're a week on bed rest, it takes over a month to recover for each week. You lose muscle based on if you don't use it. And so that's called atrophy. Unfortunately, a lot of times atrophy, the muscle gets replaced by fat then. And so hypertrophy is the opposite of that. It seems kind of odd to show a baby like this, but this could be certainly a disorder. You should not see muscle definition in babies. Okay, their muscles are not meant to be that way. So you could have a hyperactive muscle system like that. Hypertrophy can be bad, especially when they're growth plates. Their epiphyseal plates are so big there, you can actually dislocate or break the bone, damage the tissues based on that. So you got to watch how you control the hypertrophy in littler kids or even middle school age. They start getting in the weight room. You got to go low weights, guys, and go very slow with that. Muscle building due to use is just in general called hypertrophy. It could be a disorder. Okay. Other muscle disorders is an inflammation due to infections called myositis. We have other ones called muscular dystrophy, where the muscles is a genetic disorder. The muscles are breaking down and getting replaced by fat. It's almost like an atrophy, but it's genetic in nature, and you can see the progression of the muscles in very short lifespan for people with muscular dystrophy. Nobody knows why Jerry Lewis did a telethon for muscular dystrophy, but he used to have this 24-hour telethon where he'd have all these entertainers raising money for the genetic research of it. So that's why I showed his picture here. We have other ones called myasthenia gravis. The acetylcholine receptors are attacked. So the nerve is firing right. We got the acetylcholine and everything that's being released from the nerves. But the problem is on the cell membrane, it's not recognizing the acetylcholine. So the muscles are basically being, the result is, person gravis, meaning like a grave expression. It's almost like a person had a stroke, but it's actually not because the nerve isn't firing. That's what happens with the stroke. It's the nerve is firing right, but it's the receptors themselves that are not being stimulated. So that's kind of the problem with myasthenia gravis. So to sum up, I know we had the other components of this chapter within the muscle composition, the sarcomere, and the sliding filament theory. Those were 3 separate lectures, but I wanted to make sure we had some other ones in there, including all or none response, and then those other topics that we just covered within this video. So that should cover everything for you guys, and I wish you luck.